Welcome friends to the lecture number 1 of units and measurement. Today we are going to cover this topic in detail. This topic is very important for competitive exams and also for boards. Following topics we are going to cover in this particular chapter. First is system of unit, then dimension analysis, then significant figure, order of magnitude and error. Let's start with first topic of this chapter, which is system of unit. We have four system of units: CGS system, MK system, FPS system and SI system. Next we have physical quantities. We have three type of physical quantities: fundamental physical quantity, supplementary physical quantity and derived physical quantity. In fundamental physical quantity we have seven type of fundamental quantities, which are length, mass, time, temperature, electric current, luminous intensity and amount of substance. Mass, kilogram, second, Kelvin, ampere, candle and mole are their respective fundamental units. Secondly, we have supplementary quantities. We have two supplementary quantities: plane angle and solid angle. Plane angle have its supplementary unit, which is radian, and solid angle have its supplementary unit, which is radian. Thirdly, we have derived physical quantities. These quantities are derived from fundamental and supplementary physical quantities. These derived physical quantities are all physical quantities other than fundamental and supplementary physical quantities. In this chapter we have next topic, which is dimension analysis. What does dimension analysis does? Dimension analysis are mainly used to determine relationship between fundamental and derived physical quantities. So for finding dimensions we use following notations, and we use this notation under this square bracket. Now let's try to find the dimensions of speed and force. So we have formula of speed, which is distance upon time. Now distance is measured in meter, which is the fundamental unit of measuring length or distance, and we use second for time. So we can write meter, which is unit of length, as L, and second as T. So our dimension become L raised to 1 and T raised to -1. Second, let's try to find the dimensions of force. So we have force is equals to mass into acceleration. But for acceleration we have not any physical quantity, so we can convert acceleration into displacement upon time square. Let's start to find the dimension of force. So for mass we have notation as m, so using m raised to 1. Next we have displacement. So for displacement we use notation of length, which is L raised to 1, and for time we use notation as T. As time is in numerator we use T raised to -2. So here we have derived the dimensions of force. Now let's try to find the dimensions of gravitational constant, which is denoted by G. So we have the formula that gravitational force F is equals to capital G m1 m2 upon r square. So let's arrange this formula for G. So we get G is equals to F into r square upon m1 into m2. So just we have derived the dimensions of force, which are m raised to 1, L raised to 1 and T raised to -2. Next is radius, and radius is measured in terms of length, so we write L raised to 2. For mass we have notation capital M. Here two masses, so m raised to 2. Now our dimensions for gravitation come out to be, we have cancelled this 1 2 with this 1, so we get m raised to -1. L raised to 1 plus L raised to 2 is L raised to 3 and T raised to -2. So we get the dimensions of gravitational constant, which are m raised to 1, m raised to minus 1, L raised to 3 and T raised to minus 2. Other important formula we will derive in next lecture. So thank you for watching.